Hello, I'm Bob Ackerman, the editor-in-chief of Signal Magazine, and welcome to our Signal Media Executive Interview. Our guests today are David Thomas, a principal in Deloitte's Strategy and Analytics practice in the company's government and public services sector, and Keith Catanzano, a managing director in that Strategy and Analytics practice. David, Keith, welcome.
Hi, Bob. Thank you.
Hey, Bob. Thanks for having us here today. Looking forward to chatting with you.
My pleasure. Let me ask you right out front. As we look at communications, bandwidth, and multi-domain operations, our first area of discussion must be data. Two key words in the military today are information advantage. How do you achieve it? And specifically, how do you overcome its challenges?
Well, Bob, let me share with you some of my thoughts on information advantage. And I think it's important, when we open up the topic, to look at it from the perspective that Deloitte has as both the largest global consulting firm and a firm that serves both clients in the government as well as the commercial market. So if you think of information advantage from a commercial standpoint, it's having a unique set of information that gives you an advantage on how to run your organization, how to create a new revenue stream, reimagine products, or redefine your workforce. When we think of it from a government standpoint, we pull a lot of those same lessons learned, those same insights into our thinking of an information advantage. But we focus on how that same data can be an asset, but in this case, an asset for operations that include joint all-domain operations, decisions that include senior leader decision support and executive analytics, things highlighted in the OSD memo from earlier this calendar year. I think in both environments, commercial as well as government, there are a couple of challenges that we see in common, one of which is around data discovery. So there's a certain amount of, call it entropy with data management. That is, without a bit of attention, there's going to be a gradual decline into disorder of our data sets. And so that means that data is going to live in different locations. There may be some cases where we want to consolidate it, but for the most part, we're going to need to access data across a fabric, access it virtually so it stays where it lives. We also have the challenge of data readiness. That's things such as discoverability of the data, availability, cleansing, bias within the data. One of the risks we see within the AI ML space is biases reflecting decades of data that has been collected and is now being repurposed for AI or for machine learning. And so we look at both technical approaches for addressing the bias, and we also look at ways of creating project teams to be attuned to or aware of where we may see biases within the data. And then finally, I think there's a challenge, again, we see both in the commercial and our government clients, that getting value out of machine learning isn't about just fancier algorithms. It's really about making it easier to use. So I think a couple of lessons we've taken is that our data science teams need to be closely tied to business or operations teams, look to domain experts, if you will, to help determine key variables. And also remembering that, in many cases, done is going to beat perfect. So that is a model or an analytic exercise that is done and can be put in the hands of a user and then iteratively improved is often going to pack more of a punch than getting one that is perfect right out of the gate. And I think one of the big hurdles we see within the data science realm is getting past some of the technical challenges and really thinking about the change management challenges. So that's just a quick summary, again, with the lens of a company that is both commercial as well as government oriented in our analytics and data science on how we think of information advantage.
And what I would add to that is when we think about information advantage, it's not just about having more data. It's about pushing that data into a place where we can turn it into information to make better decisions than our adversaries, faster decisions than our adversaries. And that cycle time from data collection to decision, whether it's being made by a human or by a machine, is incredibly decreasing. So we're looking at all sorts of ways to bring technological improvements as well as domain understanding to reduce that cycle time. And as we talk here for the next a little bit, I think that's something we'll hit on a couple of times, is how do we continue to reduce that time from data collection to better decision.
Okay. One thing I've read is that one approach to solving the challenges at both the edge and the core involves math models. How do you leverage these models effectively, and what is the most important element in this approach?
So, Bob, let me offer you a couple of thoughts, at least from our experience in the defense and national security clients that we serve. With all of the mathematical modeling that we're doing, one of the core principles that we hold is really around the talent that we pull together. So when we think about addressing some of the challenges that David and I mentioned earlier, what we have found to be a successful practice is forming a multidisciplinary team: data scientists, engineers, software application developers, UI, UX experts, and of course, domain expertise. This delivery model, this is something we call a starfish model, but this really helps to accelerate creating an information advantage, creating models that you can put into the hands of the user. And as we think about expanding what we do both across our client base and as we open up new offices across the geography, it's really oriented around this multidisciplinary team and creating a delivery model that reflects that expertise. So as you may be aware, we are establishing a physical presence in Augusta, the concept of being on the ground with our clients so that we can address some of their challenges. And there we're taking a cyber first approach to build out our workforce and training. But as we do that, we're building our presence in that geography with those clients by creating multidisciplinary teams that can bring services from across Deloitte's offering portfolios. And I think we see that really serve our clients quite well across the range of projects that we support. And in this space, we work with a set of clients and on projects that really cover the full life cycle of data analytics, from infrastructure on the one hand, where we are working with clients such as the Joint AI Center as their prime integrator, to design, develop a cloud-based environment to develop, test, and serve as a pre-production environment for AI and ML tools. Other clients, such as our Army's Office of the CIO, where we help build out the strategy, some of the policies for data stewardship and data management practices. And then finally, some of our clients where we are designing and building AI algorithms for looking at maintenance issues, readiness, health and human performance of the force. Across all of those different projects and across all of those different clients, we do work to create the algorithms, embed them into software applications, but we do so using that starfish approach, or that multidisciplinary approach that we found works quite well.
And the math is obviously incredibly important. You can't get the models without the math. But what we find is the math is only one part of it, right? Often a model will converge, you will get an answer, but without that domain expertise, you don't realize that the model is making a ridiculous prediction. Or without that data engineer, you may have a great model, but when it goes to put it in production, you don't have a pipeline to get the operational data to it to make an inference or a prediction that's useful. So that entire team is incredibly important in actually getting these models into a place where they are not just leveraging data, but they're creating that information advantage. They're helping make those better decisions because the decisions are valid, because the model has been leveraged with a domain expert. We have a UI UX person who's thought about how that information is actually given to the decision maker, and then they can make those decisions more quickly. We have the data engineers and the software engineers making sure that all the pieces come together. Without that whole team, it really doesn't work. So the question is great. The model is an important part, but it's by no means the only part of how we create these advantages.
Okay, but data has always been important. What's different now?
Yeah, it's a good question, Bob. And I would say what we're seeing is a continuation of a trend we've seen for a long time. So data has gotten bigger, data has gotten faster, data has gotten more and more variety. But what we're seeing is that increasingly we're able to start to pull signal out of all of that data, and we can process it in a way that we weren't able to previously. So even though we're adding exponential amounts of data, we're adding exponential amounts of compute, exponential amounts of storage, and exponential amounts of methods to actually pull signal out of that data. And so we're seeing that really driving the need to get more data. We're seeing adversaries also processing increasingly amounts of data, and to get that advantage, you have to stay ahead. I think the other big trend that we've seen much more recently is a blending between the operational data and the analytic data. When you think about AI and ML, it's no longer about how do I collect a bunch of data, take it offline and process it, and then make a decision. It's much more about how do I process it quickly? How do I get insights from that data as it's coming in order to react almost real time with, or in some cases actually real time with the operational environment. So the big trend we had seen, people who studied data management years ago, thinking about I have my transactional system and then I'm going to move it all into a data warehouse. That model is really breaking down, and AI and ML and the drive to create all this information from the data is really pushing those two domains closer and closer together. And so we're starting to see a need to have closed loops in data, and emerging architecture patterns like data meshes, combining in that operational data and that the analytic data as well. So I think that's some of the big trends we're seeing that's really changing how we're thinking about data in order to continue to drive towards this informational advantage.
And Bob, I might build on that with one point. Dave mentioned the concept of a data mesh. So, at least within the defense clients that we work with, some of our national security clients, data lives in a lot of different platforms. And so, once upon a time for an analytics exercise, we might have created a data lake, pulled in what we needed, spent some time building models, testing them, and then pushing that model out. There may be a couple of use cases where that still makes sense, but I think more often than not, the idea of a data mesh, that is something that is going to begin connecting those different data platforms, is really, an answer that's much more scalable, and scalable for a lot of, different reasons. One, obviously technology in terms of not trying to move lots of heavy data to one spot, but also just from a way we operate standpoint. In other words, if I have a data platform that I own, chances are I have a lot of data use agreements already in place. I have a lot of concerns around protecting the integrity of that data. The idea that I'm going to pick it up and just copy it and hand it off to another, kind of third party, that just takes a lot of, concern, security, and just cultural issues. Whereas if we say we're going to create a mesh that allows people with the rights to access it, with the right privileges, the right need to access it, to get to it, but you still control the data, it's there, it's available, discoverable through that mesh. I think that makes a lot more sense. I think that is how we're going to start to see a lot more impact in terms of bringing disparate data sets together.
Tell me, looking at the big picture, what would you say are the key lessons that organizations must take into account to gain insight from their data?
Yeah, there's a couple things that I would say are both kind of in the to do category and the not to do, and certainly ones we've seen from interacting with clients. I'll start with a couple of things that I think are really important, and to make sure you do in order to leverage the data, and then maybe touch on a couple of those things you shouldn't do afterwards. So I think the first piece that we've seen has really accelerated people's ability and our clients' ability to get value out of this data is putting much more rigor into how we think about data and data processing. So traditionally, we've seen sort of a tale of two teams, if you will. We've had this agile revolution or DevOps revolution in the software side, and we're just now starting to see a lot of that same discipline moved into the data space. So how do I make sure that I can have an agile data environment, make changes to my data structures quickly, connect data sources that weren't connected previously, and really optimize around the ability to change the data landscape. As we think about things like AI and ML, ultimately what we're building is pipelines to enrich, process, and change data. So I'm going to be adding features, or I'm going to need to store it in a different way. Maybe I'm going to need to store it in a vector database to have really quick search lookup. So we're constantly changing our data landscape. And in order to do that at scale, you need to put in the same engineering rigor that we do when we build software. The other thing that is really important is to not think of data, any data system is closed. Think ahead of time about what are the open APIs that I'm going to enable to get my data out of my operational systems. And it's naive to think that when you're starting to put a new system or a new capability in operation, you're going to know all the way that data is going to be used, and to think ahead of time that we're going to be able to process it in some sort of closed system. You really need to think about how do I use open APIs and standard APIs to enable that data to come off of those operational systems in order to be processed and leveraged to get more of that signal out of that noise later. A couple things that I think go wrong is people don't start to think about combining the data together. So they've built barriers between different systems and think of a domain as sort of a vertical rather than as a mesh. And so when we talked about data meshes earlier, one of the key things there is having multiple domains data domains where you do have expertise and knowledge and governance in that domain, but it's not disconnected from the other domains. And as we think about multi-domain operations, explicitly, you have to start to combine some of that. And that signal that you get from combining those is critical. So I think those are some of the big things that stand out to me, and where we've helped clients and where we've seen challenges in previous engagements around really leveraging data to its maximum extent.
Dave, the only thing I would add to that, I think that's spot on. The only other lesson learned, I think, is because so much of the data is being used to either present a dashboard, a decision aid, or inform a model. I think one of the other key lessons learned is really thinking about the user experience, the user interface upfront. There's some really great practices that we've done that other companies do around creating clickable demos so that you can put something into the hands of the user before you even start working with the data, start working with the code, figure out how somebody wants to interact with that tool, that decision aid, and then from there begin to work backwards to identify what's the data, what's the math, what's the underlying workflows that I need to implement. And I think that's really where we've collectively within the government space, we've taken lessons from commercial, especially our own personal interactions with technology, whether it be through our phone or other mechanisms, to really take that human-centered UI, UX approach to looking at data and looking at analytics and AI.
Gentlemen, I'd like to throw you a follow-up, if I may. Bit of a curve, but you both mentioned AI and ML. How are, in your opinion, AI and ML going to change the rules of the way companies handle data, companies and defense organizations?
There's a number of ways. I think we've already started to see it happen. And I think there's a huge runway for the potential that's still there. A lot of what we've started to see already in the AI ML space is some of the operations behind the scenes for things like large scale systems are starting to be handed over to AI and ML. So if we think of things like AI ops, So we have massive systems, way more complicated than any human system, or group of humans could run, can be handed over and operated with AI assistance behind the scenes. And ironically, what that means is we can start to collect more data, we can start to process more data, because we're able to continue to scale up some of these systems to ways we haven't had before. I also do think it's important that the AI/ML increasingly gives a focus on collecting data, but also building the required pipelines to process that data. And so we see a huge amount of investment in companies and in the government, and not just collecting that data, but thinking through, how do we process that data? How do we refine it? How do we get signal from the noise? And I think scale, it continues to drive scale and investments in scale and processing, scale and storage, scale and networks. So the AI/ML, the objectives of getting information out of all this data is sort of becomes a closed loop, and that it means we need to collect more data, so we need to process more, so we need to get more data, and we see a cycle of increasing scale in sort of every part of that domain.
Yeah, and the one thing to build on that point of the impact AI/ML has on data, whether it be data ops, I think that the trend we see now is we don't let data go on the floor to the degree we can help it. We look for data pipelines that can continuously, as Dave mentioned, ingest new data and can bring data in a manner that is usable. We also look to preserve the pedigree of that data. So for example, if I pull in 3 or 4 different data sets, combine them for some model, I want to then be able to go back and confirm the lineage of that data before I put that model into operational use. I want to know what's the provenance of the data, who touched it, how secure is that supply chain of data, so that I know that the model that is built from it is also secure. So I think that that's an element of the impact AI/ML has on data ops and data lineage that we need to be mindful of.
And actually, building on that, just one more second, I think one of the really interesting things that we've seen with AI/ML and the human interaction with it is a bit of a change of how we think about computers. We're used to computers being binary; they're right or wrong. They give a yes or no answer. And in the AI/ML world, we're talking about probabilities, and that can sometimes be really hard when we have computers working alongside of humans and helping humans make decisions, but not replacing that decision, augmenting it. And so they may be bringing a lot of information, and they may be making a prediction that has some sort of probability distribution. And that interaction between the humans and computers that we see in a world informed by AI/ML is a really interesting change in how humans are interacting with our machines. And I think we'll continue to see that, and I think that'll be a really important area as we continue to move AI/ML into these mission critical spaces. How do we get that human interactions with AI/ML right? Very interesting space that we'll see over the next few years, I think.
Okay, then. Gentlemen, any final thoughts for our audience?
So I'll offer 2. One, I think when we think about information advantage and data in the way that we've been discussing, one of the things that has always struck me is those types of projects can become incredibly complex very quickly. And I think it's important for anyone working on that kind of effort to take not just a technical perspective, but really a consultative perspective to look at, how do I take all of this complexity, pull it together, and create something that's going to work, and then iteratively improve on it. So I think that consultative approach is really key for information advantage success.
Yeah, and the last thing I'll add is Deloitte's excitement to be in the Augusta market. We're really excited about getting to operate in this domain, or I should say, continuing to operate in this domain. We're spending a lot of time and a lot of investments and making a lot of impact in the cyber realm, but we really see a lot of the same forces that are driving AI or data exploration in cyber will also move to other domains as well. So excited to be present here with the folks in the Augusta area, and looking forward to continuing to talk about how we can take this data to create information advantage.
Back to those original two words, information advantage. Well, David and Keith, I want to thank you for your insight and observations. To the audience, I want to thank you for viewing. This has been a Signal Media Executive video. Thank you again, and good day.